All right, hello once again. This is Jeff Scott at Blackhawk Technical College, and I'll be coming at you right now with Chapter 7, the book presentation from our Starting Out with Java 6th edition book for the 152. It's by Tony Gaddis for the 152, 143 Intro to Java Programming class for the Spring 2016 semester at Blackhawk Technical College. We're going to talk arrays right now and get an introduction to arrays, talk about how to process array elements, how to pass arrays as arguments to methods, some useful array algorithm operations, how to return arrays from methods, string arrays, arrays of objects, sequential search, two-dimensional arrays, 3+ dimensional arrays, selection sort versus binary search, command line arguments, the array class, and then the common errors. So an array is a data structure. And what I mean by that is, as it says in the definition there, an array can hold multiple values of the same data type simultaneously. So it can hold an entire collection of integers. So for instance, if I wanted to do this, I'm going to grab this example here, but I'm going to change it a little bit. Let's suppose that I wanted to create scores, all right, for all my students. I could do this if I had 25 students in the class. Now, that's the way it's typically done in Java, just so you know. If I'm doing that same thing in C, then I do it like this. And I put the number there. But the big thing I want you to realize is it's int bracket bracket versus it's int bracket bracket variable name versus int variable name bracket bracket. And the only reason I'm showing you this is I want you to understand that if you want to, you can do it like this. That is legal in Java. It looks like C, but it's legal in Java. But we're just going to do it this way because that's the way that it's typically done in Java. When you create an array, it's kind of like the examples that I usually give are like saying that, for example, right here, when we created an array that was called numbers that we said had 1, 2, 3, 4, 5, 6 elements in it, since we're computer people, we start counting at 0. So that's element 0, element 1, element 2, element 3, element 4, and element 5. More often than not, that is going to be called numbers sub 0, numbers sub 1, numbers sub 2, numbers sub 3, numbers sub 4, and numbers sub 5. Sub is short for subscript. You can make arrays of any kind of variable. To access an array, again, you look at their subscripts or their indexes. It goes by different names depending on the way that you read it. So this is typically read numbers sub 0 equal 20. Numbers sub 3 equal 30. But what it really means is take the value 20 and assign it to our 0th location. Take the value 30 and assign it to our 0, 1, 2, 3rd location, or 3 location. So after you do this, this is what it's going to look like, the 20 and the 30. By default, notice the note here on page 408. By default, Java initializes array elements that you have not initialized yourself. It initializes them to 0. Now, arrays work great with loops, just so you know that. All right, we're going to get into that in just a little bit. But arrays and loops really do work hand in hand with one another. Also, it is possible, if you want to do so, that we've set up a constant here, and then we said the array is of size followed by that constant. You can do that. All right, will it really buy your program a lot? You can do that. It's up to you as to whether or not you think it buys your program a lot. Okay. And I don't like the way, I don't even know if this would work, what the author has right here. All right, I'm going to grab all of his, well, I'll tell you what I wish he would have done right here. Let me grab this stuff up through here. copy it, and I think it worked a little better when I threw it out into Notepad as opposed to throwing it out into Notepad++. And I just want to show you something I wish the author had done but didn't do. All right, again, this is not a complete program, and I'm going to cut down the size on this because it's way too big right now for you to see everything. So here it says index less than employees, and I guess that would work because that's the, all right. So actually that would be fine to do that. But more often you'll say the name of the array, which is hours, dot length. And I believe it's got parens on the end. You're going to see that in just a couple minutes. That's typically how it's going to be done. Again, I think it has the parens on the end. He explains why he uses that constant value right here on page 411. You can read that yourself. Java automatically performs array bounds checking. So if you do something illegal, okay, it says here new int 3. So it's going to have 3 elements in it. Element 0, element 1, and element 2. But here we're saying less than 4, which would be a mistake. So you get what's called an array index out of bounds exception when you attempt to read too far into an array. Another thing you have to watch out for with arrays are what are referred to as off by 1 errors. So here we're saying that the size of the array is 100. So it should go from 0 to 99. So this should not read like this. Again, let's just grab the code that's in here. All right. So what the author has here with this for loop, just put a little bit of white space in here to break it up a little. What he should have written instead of this for loop line that's in there currently, which is not correct, all right, instead the author should have written, instead of equal 1 less than or equal to size, it should have been equals 0 less than size, which would have gone, so this attempts to go from 1 to 100. That's wrong. That's not the size of the array. The size of the array is 0 through 99. You can't initialize an array when you declare it. So in other words, that's putting values into those array locations. If you do this, do not put a number in here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements in here, elements 0 through 11. But don't put a 12 in there. Leave it blank. Let the system fill it out for you. That's what's considered a better way of doing things. All right, this is what I mentioned before, that you can do it either way. This is the C way of doing it, but sometimes people do it that way anyway because they've learned C before they've gone in and learned Java. All right. The individual array elements can be used and accessed just like any other type of variable. So an individual element, you can add to it, subtract from it, do anything you want with it. If you pass an individual array element, not an entire array, but an array element, if you pass that array element into a method, it's passed by copy. So if you do happen to change anything, it's just changing the copy. If you pass an entire array into a method, since an array is an object, you pass a reference or an address to the array. And any change you make is just made to the address. There's the array length property, and I was wrong. There is no paren in there. So the example that I showed before, probably don't even have it on the screen. Let's see if I still have that one or not. Nope, I don't. All right, so we've got numbers here. We could have said, instead of less than or equal to size, we could have said numbers dot length. And you do not in this case. You do not. Put in parentheses after length. I was mistaken. All right, there's an enhanced for loop that you can use. So if you look at this, let's just look at how you do it with the enhanced for loop and without an enhanced for loop, okay? So there is the enhanced, and here we'll rewrite it with a non-enhanced for loop. So there it is with the enhanced for loop. Numbers is the name of our array. Int val is something we're just making up on the fly. So that's going to print out all the values. The other way we can do it is we can say for int, let's just say x equals 0, x less than numbers dot length x plus plus. The next value is, so here we'd say numbers sub x. We could have used val instead of x in there also if we wanted to. So you notice that the for loop that we created up above, the enhanced for loop, is a lot more compact than this one is. They both do the same thing. Now, if you use this enhanced for loop that they show here, and it's also in your book, all right, the author mentions you cannot use it if you need to change the contents of the array, or if you need to just work with some of the elements, or if you need to change the, the order in which you read things, or, so there's a bunch of caveats. The enhanced for loop is nice to use if all you want to do is read through the array from start to finish. Then it's fine. Other than that, because I never use it. All right. Here we're displaying test scores. Remember, when you use index or LCV or X or whatever, this is a placeholder. So for the first test, that'll be test 0, then test 1, then test 2, etc. So it says how many tests you have. Here it says enter test score 1, and the reason it says a 1 there is we said index plus 1. That's just in our print line. That's not going to change. That's still a 0th element. All right. This is a little confusing with the reassigning array elements. I don't even want to go through it. When you copy an array, you can't do this. When you copy an array, since it's an object, you must copy one element at a time, so you do it inside of a loop. So you do it like this, where you copy the first array to the second array. Okay? I've already mentioned when you pass an array as an argument to a method, it is passed by reference. So the address passes, and if that's only if you pass the entire array. And if you do pass the entire array, any change you make to it is a permanent change. And that's exactly what they say in this programmatic example here. Some algorithms and operations for working with arrays. I'm going to show you a different program, I think, for this chapter. We'll do 2 programs. All right, and the first one I don't have written, so I'm going to do it on the fly. So it'll be interesting if nothing else, but I'll show you averages. I'll show you high and low. And it'll be similar to the one that you see right here, but I'd rather do it just off the top of my head and see how that works. Okay, so he's got another one of these spotlight examples here. There are always very good examples. There's just not enough time to go through all the stuff in here. You can have an array of anything, including an array of strings. So here's a list of names that we've set up as a string array. So it's going to look like this in memory. Remember, an array is an object, so what it has is an address which points to where in memory the particular element is. So here we've set up a string array with the months, an integer array with the days, and we're using index to go through both arrays. So we've got parallel arrays. They each have the same number of elements. So we can use the same loop control variable to loop through both of them. January has 31, February has 28, etc. Kind of a neat example. All right. If you set up a new array like this, or any array like that, it's empty, so you have to fill it up an element at a time. The big thing about arrays is arrays are set at compile time. They're what are known as early binded. You cannot change the size of an array in Java once you've created it. If you want to be able to change the size, then rather than an array, you want to use an array list, which we haven't gotten to yet. Array lists are late binded, so they're set at runtime. You can have an array of anything, including an array of objects you create. So if we create a bank account class, we can make an array of bank account objects and work with them any way we want to or need to work with them. All right. Sequential search algorithm. Again, I talked about this when we went over this in the PowerPoint presentations. But a sequential search says you start at the beginning, you go all the way through until you either find what you're looking for or you get to the bottom and you find out it's not there. The sequential works nice in that it works on things whether they're in sorted order or not sorted order. So in other words, if I had a list of numbers, and you and I would know this, but let's say that I'm the computer and I've got a list of 10 numbers and I'm making these numbers up. 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want to know if the number 57 is in there. And if I'm doing a sequential search, I go no, 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 no. So I know I've gone through the whole list. So typically what I'll do is if it's a sequential search, I'll return -1, which means it wasn't there. If I ask, is the number 456 there? No, 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 yes. So that's in location 0, 1, 2, 3, 4. So if I was going to return the location, I would return location 4. So if you use a sequential search, it's very slow, it's very laborious, but it works even if your list is not sorted, the list of values that you have. All right, a two-dimensional array is like a spreadsheet, except with a spreadsheet that's A, B, C, D, 1, 2, 3. But here, going across, it's column numbers rather than letters. And here it's row numbers, but they both start with 0. So this is location row 0, column 0. This is row 2, column 3. You'll notice that there are 3 rows and 4 columns, which means, do the math, 3 times 4, there are 12 elements in the array. This is how you set up an array like that. You always put your number of rows first, followed by your number of columns for a two-dimensional array. That's again how you read it. It has 2 sets of brackets. And to go through it, you'll need 2 different for loops, one for each dimension. All right, so you go through and you do all your, so for row 0, you do columns 0, 1, and 2, let's say. Then you go to row 1, 0, 1, and 2, row 2, 0, 1, and 2, etc. So they go through several examples in here on how to do this. My hope is that by going through this fairly quickly and then writing an example for you, that'll make it easier for you to understand this. Okay? All right. You can do operations to display all the elements in a two-dimensional array. You can sum them. You can have a ragged array, which means not each row can have a different length. So notice here, there I've got 3 columns, there I've got 4 columns, there I've got 5 columns, there I've got 6 columns. And it'll work just fine if you want to do that. There may be a reason for wanting to do that. You can make arrays of 3 or more dimensions. It's not done often, but I guess, again, especially depending on the type of application you're using, it might make sense to do that. All right. All right, selection sort and binary search. With a selection sort, it's a swapping mechanism. So in other words, I go through the whole list and I find the smallest value and I swap it with wherever it is, I swap it with whatever is in the first element. So notice it's at the end, so I'm going to swap the 1 and the 5. Then I go through it again, but after I do it now, I don't have to do element 0. So I go through this again. 2 is already in the right order. So now I go through it again and I can skip these two and boom, boom, boom. And I swap the 5 and the 7. Now I've got 1, 2, 5, 8, 9, 7. So I do it again. Now I've got 1, 2, 5, 7, 9, 8. So I do it one more time and I have 1, 2, 5, 7, 8, 9. And it's finally in the right order. All right? And that's what they show in here. And they even show you the way to code it. A binary search algorithm is a halving type of. Now let's change this. So let's now put this so it's in sorted order. All right, so I'm going to put the same thing I had in here, but I'm going to put it in sorted order. So negative 999. Oops, I guess the first one would be negative 2345. Negative 999. 0. Let's get rid of them as we have them in here. So negative 2345, negative 999, 0, 6, 7, 34, 88, 123, 456, and 555. I believe that's all correct now. 1, 2, 3, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now if I want to know, is the number 5, let's put something in the middle. 200. Is the number 200 in there? Well, I take my array and I split it in half. So I go down 1, 2, 3, 4, 5. So I'll go down to right here. And I say, is this the number? If it was 200, boom, I'm done. But it's not. So I say, is the number greater than this or less than this? Well, it's greater. So now in one guess, I've removed 1, 2, 3, 4, 5, 6 things from my check. So I come down to here. And I say, is that the number? No. Is it greater? No. Is it less? Yes. So now with one guess, I've removed 1, 2, 3, 4, 5, 6, these 6 things, and these 2 things. So I look again. And I say, is this the number? No. Is it greater than or less than? If the number is greater than, well, I've already checked these, so I know the number is not there. It's a halving sort. So let's play a quick little game to show you how this is done. All right? I'm going to play a game. And even though I'm going to show you the number, I'm going to pretend I can't see this. I'm going to try to have a number that's between 1 and 1,000. And I'm going to see how few guesses I can make to guess the number. I'm just going to make a number up at random. So I'm going to pretend I can't see this. But I'm going to say the number that I can't see is 871. All right, so my first guess, I say 500. I guessed right in the middle, and you say it's higher. So my second guess is 750. Oops. You say, no, it's higher. So in 2 guesses, I've removed 750 of my 1,000 possibilities. So I break it up again. And I say 750 and 100, 875. It's lower. So now in 3 guesses, it's got to be between, I've got 1 through 750. Those numbers are gone. All right. 875 through 1,000. Those numbers are now gone. And I've done that in what? Just a couple guesses. All right. So I guess again in here. And I say, okay. So I want about half of that. Let's say I put in 800. All right. And you say, no, it's bigger. Now all the numbers between 1 and 800 are gone. So I guess again. I say 850. You say, no, it's higher. Now it's every number in there is gone. So I say 875. No, I already did that. So I'll just say 870. And you say higher. Now all these are gone. I've made 1, 2, 3, 4, 5, 6 guesses, and I've eliminated what? 870 values here. And down here, what? 125 values? Really 126, I think. So in 6 guesses, I have now removed 996 of my possibilities. So I know that with what's left, that number that's left has to either be 871, 872, 873, or 874. So again, I guess right in the middle. I say 872, and you say higher. So now I know it can't be these numbers. Or I'm sorry, you say lower. So I know it can't be any of these numbers. So now the numbers from 872 through 1,000 are gone. So the only number that's left after making just 1, 2, 3, 4, 5, 6, 7 guesses is 871. That's a binary search algorithm. You keep doing what's called a halving, H-A-L-V-I-N-G. All right, they show you how to do that in here. All right, command line arguments on page 471. It is possible for you to pass information in to main. So they've got an example here if you ran it from the command line. Java command line, that's element 0. How does this work? And then you get the output. And you print out all of the different elements that are in there to main. Now I'm going to let you read that on your own because we're not going to do anything with main. There's nothing wrong with it. We're just not going to use it at all. You can also have variable length lists. This is a relatively new thing in Java. If you say this, all right, when you look at that right now, what that says is this is called a var_arg parameter, which says that numbers can be of varying sizes. And the reason that that's nice is I can call that and I can pass in, first I could do it and I could say pass in an array called numbers that has 10 elements. Then pass in another one. What if it's my students and I want a class average? And I've got 4 classes, one with 10, one with 20, one with 25, and one with 15. I could pass each one of them in there because it's a variable number. All right, they give you a demo of it with a bank account. Let you look at that on your own. All right, the chapter ends with, starting with the last 15 pages or so, talking about the ArrayList class. Again, unlike an array list is late binded, so its time is set at runtime, so it can change. As it says, an array list can automatically expand or contract as the program's running. The syntax is different. Array list, and then you put inside of angle brackets the type, then the name of the array list equals new array list. That type has to be the same as this type. And then paren. And these parens are, by default, it makes a list that I believe has got 16 elements in it. But you can put a different number in there if you want. If I wanted, I could put 1,000 in there. Or 1,000,000. There are different methods that you can use with array lists. You can use the enhanced for loop. But when you want to add things to an array list or remove things, there's a remove method. There's an insert method to add things. Again, I'll let you read this. All right, if there's time, depending upon how late into the semester we are when we get to this, we may go through and spend a period and do an array list example. All right. With an array list, I guess it's automatically 10 if you don't put a number in there. As soon as you get to the 10th item, it automatically doubles it and makes it 20. So here we're making it 100. As soon as it fills up, it will automatically change that from 100 to 200. And what we see in here is string. You could put any one of the 8 primitive types in here or your own type. Bank account, bank account. All right. That's pretty much it for the chapter. So I'm going to come back and I'm going to actually do 2 more lectures for Chapter 7. The next one, I'm going to do some kind of junking around with arrays, and then we're going to come back to the payroll program. All right? And after we get done with that, the next chapter that we'll be going over is, I believe, a fairly short chapter, and it's a second look at classes and objects. So we'll do that. After that, we'll go through Chapter 9, which is another fairly short chapter on wrapper classes. Okay? And following that, we'll have Chapter 10, which is on inheritance. And then finally, Chapter 11, which is on exception handling. And that'll be the end of these lectures for this semester. Okay? All right.